Hello. Let's try to understand the cofunction identity graphically. Okay, this is very interesting. We can do it algebraically also, as we've done in many examples. But here we'll try to understand it graphically. Okay, so I hope you remember the cofunction. Otherwise, you can look into my video which explains cofunction identity. Okay, basically, let me summarize it here. For sine, cofunction is cosine, and for tan it is cotangent. So these are like cofunctions. Okay, now so what really happens is when we do, let us say, sine pi by 2 minus theta, what do we get? We get the cofunction, right? Because in the right angle triangle angles are complementary, right? Okay, all this explanation you can go to cofunction identity video and then see, but basically it means sine pi by 2 minus theta or sine 90 minus theta is cos theta. And if we have like sine pi by 2 plus theta, then also it is cos theta, right? So sine and cosine are cofunctions, but when you do 92 plus or minus theta, sine changes to cos. Similarly, if we have cos of pi by 2 minus theta, what do we get? We get sine theta. But if it is cos of pi by 2 plus theta, then what should we get? We actually get minus of sine theta. Why minus? Because cos pi by 2 plus theta happens to be in quadrant 2. So we are expecting a negative value for cos, right? Remember the cost rule? So we have CAST, right? So because we are expecting a negative value here, but in quadrant 1 everything is positive, so we have to write negative of sine theta, correct? Now in the problems, normally what I find is very difficult for students to write an angle into its cofunction form. Let's try to do one problem. For example, we have a problem here which says given sine 3 pi by 10 is equal to 0.8090, right? You need to find the value of cos pi by 5. So when a question like this is given to you, a hint is there that somehow these two numbers are related. Okay, so that's kind of a hint. Now when you look into this kind of a problem, you are given sine and you want to find cosine. That means you have to look for cofunction identity. So that's the straight hint. Look for cofunction identity. Correct? Now second part is, well, we know that this should be a cofunction. That means it should be 90 plus or minus something. Is that okay? Right. So what we are trying to write here is we want to write cos of pi by 5 as 90 minus something, right? That's what we are interested in finding out. Now how to do that part, right? So I will show you how to do it graphically. It can be done algebraically also. I may get into that details also in here, but those details are given in a separate video. Okay, let's first understand what is sine 3 pi by 10. 3 pi by 10 really means that this pi is divided into 10 equal parts. When we say 10 equal parts, that means 5 on this side and 5 on this side. So let's do that division now. Let's say I'm approximately doing it. Okay, 1, 2, 3, 4, and this becomes 5. Don't forget this 5, right? So we have now 6, 7, 8, 9, and that becomes 10. Okay, so we have 10 equal you have to assume them to be equal, right? 10 equal parts. Now when we say 3 pi by 10, then where do we land? 3 pi by 10 means from here, this is my x-axis and that is my y-axis, right? Now from here I go to, this is 1 pi by 10, so there are 10 equal parts, so this is 1/10 of each, right? 1 pi by 10, 2 pi by 10, and this is my 3 pi over 10. Does it make sense to you? Right. Now we are looking for a cofunction which relates 3 pi by 10 with 90 minus what? You can see from here that this is your angle theta given to you as 3 pi by 10. So what is the cofunction of this? What will make it complementary angle? So the complementary angle is the angle which when combined makes a sum of 90 degrees. So what do we need to do? We need to add this angle to make it 90, right? How much is that? Each you know is pi by 10. So this is 1 pi by 10 and 2 pi by 10. So we are landing up here with additional 2 pi by 10. So the blue one is 2 pi by 10 and the red one you know is 3 pi by 10. If you add them, you get pi by 2. Is that okay? So this kind of gives us an answer to this, right? What is 2 pi by 10? 2 pi by 10 is equal to, you can simplify it, 2 goes into 10 5 times, so I can write this as pi by 5, okay? Pi by 5. And that is what it is, find cos of pi by 5. So now we kind of know what pi by 5 is. So if this is pi by 5, this could be written as pi by 2 minus 3 pi by 10. So I can write this as cos of, look here carefully, right? Pi by 2 means 90 degrees. Is that okay? Is that okay? 90 degrees, right? So we can write this as cos pi by 2 minus this side, right? Will give me that angle, which is pi by 5. Do you get that part? So this could be written as pi by 2 minus 3 pi by 10. Is it okay? Now from the cofunction identity, you know, cos of pi by 2 minus theta is actually equals to sine theta, right? So we'll end up with sine 3 pi by 10, okay? So here it is, sine 3 pi by 10. And since we know the value of 3 pi by 10, now we know what cos pi by 5 is. And we say, well, this is equal to 0.8090. So you understand the method? How I have done graphically. I didn't really do any algebraic calculations, right? And I got the answer just by viewing at the situation. This is a beautiful way of doing your trigonometry with radians. Perfect way of doing trigonometry with radians, okay? Now, if I have to approach algebraically, in that case, I will do it like this. Let me try to give you that solution also, right here. So we will say, what is pi by 5 in terms of pi by 2 plus or minus something? So I can write, let pi by 5 equal to pi by 2 minus some angle A, okay? And then solve for A. So I bring A this side and say A equals to pi by 2 minus pi by 5. Is it okay? Now that means I'll get 10 as my denominator, common denominator, and this is 5 pi minus 2 pi. Is that okay? So 5 pi minus 2 pi is 5 minus 2 is 3 pi by 10. Correct? Now, so I get A as 3 pi by 10, and therefore I could write pi by 5 as equal to pi by 2 minus 3 pi by 10. So this is my algebraic method of getting the same result. Do you see that? So it could be done algebraically. It should normally be done algebraically. But this is an alternate for you. For angles, especially given radians, this is a very beautiful way. It just gives you visual feeling of the whole thing. And in a second, you get your answer. And doing algebraically, you can land up in problems sometimes. I hope you appreciate both the methods. It's all up to you. You can approach either way, but you'll get the right answer. Okay. Thank you.